Welcome to this repair overview for a Behringer NX6000D audio power amplifier. The brand is owned by Music Tribe, and Music Tribe also own 11 other brands including TC Helicon, Tannoy and Turbo Sound. The specifications for the amplifier are impressive. 6000 watts of power, or effectively 2 times 3000 watts of power per channel with a 4 ohm speaker load, or 2 times 1600 watts of power with an 8 ohm speaker load. Output stage is Class D mode, and this again is typical for these large power audio amplifiers, and the amplifier also includes a cooling fan. What's interesting is that the amplifier has a 3-year warranty, but what is a little bit concerning is that the warranty is non-transferable. And what I'm referring to is if, for example, a customer bought the amplifier and then chose to sell it within that 3-year time period, the new owner of the amplifier, the warranty wouldn't transfer to the new owner. If you need to have any work done on the amplifier during the warranty period, then what you need to provide is the original purchase receipt. And that purchase receipt, of course, cannot be passed over to the new owner. Somewhat strange, I would say. For this amplifier, it came into the workshop and the service tag said that it did not power up. And on the face of it, indeed that seemed to be the case. But once the top cover was removed from the amplifier and then the power was applied via the dim ball tester, what you could hear was just a low level, like a ticking sound, almost like a cricket. So you could hear this low level ticking sound, and that indicated that potentially the switch mode power supply, which is used to power all of the different circuits within the amp, was attempting to start up but then was shutting down. And I've often described this, that when an amplifier has a protection circuit, you really need to determine whether or not it's a fault within the amplifier that is triggering the protection circuit, or is it a case that the protection circuit has an issue and that is why the protection circuit is operating. With this amplifier, when you look at the video, you can see that there are 2 boards. With the Behringer amplifier range, and I'm thinking back, say, to the iNuke series, you have a single board, and sometimes that makes fault finding a little bit more difficult, because what you're unable to do is isolate the power supply from the main amplifier. But here, it's a quick test where you can just unplug the main amplifier circuit board from the switch mode power supply and then test. And what should happen is that the switch mode power supply should start up correctly after a few seconds. Of course, you will have no display indication because you're not powering up the front panel with a microprocessor on there. And then what you'll also find is that the cooling fan would spin at very high speed, and that's a little bit annoying, but you can unplug it from the power supply board. And then once the amplifier switch mode power supply is operating, you can make the relevant voltage checks, and these voltages are indicated on the board. So there you can check for the main voltage, which would be powering the output stage of the Mosfets, and then also the plus or minus 15 volt supply rails, which would be powering the preamplifier stage and input processing circuits as well. And there's also a 5 volt supply going off then to the microprocessor. So as I said, during the initial test, the power supply was shutting down. Now, from experience, and this applies to the iNuke range and the Nuke range, the design of the amplifier isn't sort of unique. Alright, so when I look at the power supply design, it's very, very close to the same kind of design that they've used on some of the earlier amplifiers. And my attention was drawn straight away to the plus and minus 15 volt supply circuit. On the video, you can see I've zoomed in and it shows 2 rectifier diodes, which is D29 and D30. These rectifier diodes are used for the plus and minus 15 volt supply rails. And during sort of initial testing, what I'm looking for here is to depower the amplifier and then just put the multimeter on to diode mode check. And what I was able to do is just measure across the rectifier diodes, and D30 was short circuit. So that told you straight away the reason why the power supply was not starting up. Now the diode itself is a Schottky type diode, and the Schottky type diode is different to a conventional silicon diode, and they are used in switch mode power supplies but also in other amplifiers. And the reason why that type of diode is used is for two reasons typically. The first one is that it actually has a lower turn on voltage. So with a silicon device, typically with a forward bias, it will be 0.6 volts, which will turn on the device and allow it then to conduct. With a Schottky diode, it's at 0.3, and also the design of the diode means that it will generate less noise electrically than a conventional silicon diode. And whenever these Schottky diodes are used, they tend to be used in switching type circuits as well. And we understand that any type of noise which is being used within the power supply of an audio amplifier, it must be made to be as clean as possible. So if this electrical noise comes through, it will enter into the pre-amplifier stages and then ultimately then to the output stage of the amplifier, and this needs to be eliminated, wherever possible. And there's filtering capacitors which are added within the power supply and then throughout the processing circuits, but it starts at the beginning, which is the rectification of the AC then to form the unsmooth DC, and any noise elimination at that point of course will add up to a better overall audio quality. Now, just to give you a little bit of insight for the people who are listening to this audio blog, when we look at types of power supplies, a language which is used, or a term which is used, is the word a linear power supply. And what we refer to there is that is really a conventional type of design. So with a linear power supply, you would have a transformer, and that could be a transformer which has laminates, or it could be a toroidal type transformer. And then the power then would come in, it would then be switched, it would then be applied directly to the primary of the transformer, and then the transformer secondary would then either provide maybe dual tappings, so they could have windings on there which would provide the voltage requirements for the output stages of the amplifier. Of course, the wire that would be used to wind the coil of the transformer would be gauged to ensure that it could handle the current. And more commonly than not, what you have is a multi-tap transformer. So that has multiple tappings on there. Could be for the high output stages, or it could also include additional windings which would provide maybe an output for the cooling fan, or outputs then which would be derived then for the plus or minus 15 volt or 18 volt rails, or any other voltages that are required. And then after rectification, it then goes to the smoothing capacitors, and the smoothing capacitors are just really eliminating that 100 Hertz ripple that you'll see from full wave rectification. And then you'll also find some additional capacitors in there for high frequency noise elimination. Typically 100 nanofarad is probably the most common. Now in the early 80s, so this was probably about 1982 upwards, what you started to see was the switch mode power supplies which were being introduced into domestic electronics, and televisions had these types of power supplies, and they were really in their early design stages. And then once the boom then in satellite receivers and that market continued to be developed, those satellite receivers also would include a switch mode power supply. And the switch mode power supply is used for a number of reasons. First, it reduces the manufacturing cost because you don't have to have these large power transformers or toroidal type transformers. And also as well, they are actually more in terms of efficiency, and I'll explain what I mean when I'm talking about efficiency. When you look at a switch mode power supply and modern day audio amplifiers like in this Behringer type, that switch mode power supply is used to provide all the different voltages and desired current then for the whole of the amplifier. So when you look from the top, you can't see any large power transformers, but there are smaller transformers which I'll refer back to in a moment. You also see them in high-end audio amplifiers as well. So Rotel is a good example where they will use a small switch mode power supply, and NAD also will use a similar type power supply. And what this is being used for is to generate a 5 volt signal, 5 volt voltage then to power the microprocessor, and then the microprocessor then would send back a command signal to turn on a relay, which would then provide power to a conventional type transformer design. So it's almost like a hybrid. You can have a small switch mode, which in turn powers a larger transformer via the microprocessor and a relay, or as in this case, you have a complete design using a switch mode power supply. Now for this amplifier, as you see, it's really a combination of designs. So you have surface mount components, but you also have traditional components as well. So a lot of the capacitors are surface mount, but some of the higher power capacitors in a power supply, you can't go surface mount because the current is too high. What I would also highlight as well, with a conventional linear type power supply, even when you remove power and you leave the amplifier for a period of time, the large rail power supply capacitors can charge up and they can retain that charge. So when engineers are working on the power supplies and you see these capacitors, we will look then to discharge the capacitors, and normally that's via a resistor which is then connected in series then back down to ground. So absolutely don't get a pair of pliers and just short across the terminals. There's a huge amount of energy that is stored, and that will be dispersed through and probably damage the circuit board, and if not cause some injury to yourself. So it discharges via a resistor down to ground, and then we do that and just measure across the capacitor just to make sure that he's fully discharged. Or you can buy capacitor discharge devices, and they can be like a bench mount type device, or more commonly they're almost like a pincer, and they have an LED on there, and then of course when the LED goes out, it indicates then that the capacitor no longer holds charge. But in a linear power supply, like in audio amplifiers, maybe the voltage is like 80 volts, maybe topping out maybe 90 to 100 volts maximum on a very, very large audio power amplifier. When you get into the world of switch mode power supplies, you need to be extremely careful. And the reason why I mention that is that when you look at the switch mode power supply capacitors, the voltage rating on them will be very high. So it's not uncommon to see maybe a power supply capacitor which has a voltage rating of 180 volts or maybe higher. So when you come to work on a switch mode power supply, it doesn't take very much voltage. Remember, this is DC voltage that's retained, not AC. So unlike AC, if you have the misfortune of getting an electric shock, you will be repelled away from the device. The problem with DC is it's almost you kind of get stuck on the device then, and you're going to receive quite a substantial electric shock. So again, if you're going to work on a switch mode power supply, please just be aware that those power supply capacitors charge it to an extremely high voltage, and the last thing you want to do is maybe inadvertently put your hand or your finger on there, and then it then discharges through you down to ground. So caution is, make sure that that capacitor is discharged. And maybe if you're going to use a capacitor test unit, again, most capacitor test units will not tolerate hundreds of volts being applied to it. They require that the capacitor really is discharged, and it's best practice then to discharge and make sure that that's the case. With switch mode power supplies and the design of them, it incorporates what we call a pulse width modulator, and what that simply means is that when the AC comes into the power supply section, once it has been rectified, it then goes via the primary of a transformer, and I'm going to refer to that as a transformer, but not in the same context as a power transformer used in a linear type power supply. And then normally it will then go down then to what we call a chopper circuit. So there will be a power Mosfet in there, and this could be an ICFET for example, and then what the circuit is doing is it's switching it on and off at high frequency. And it's almost like a gate. So literally what it's doing, it's turning on and off. That allows the current then to flow and then to charge up the capacitors. Also as well, what you have is a feedback network that comes back. So as the load on the power supply increases, maybe the operator or the user is turning up the volume and it requires more power output to the stage, what happens is this is then fed back to the pulse width modulator, and it will then change the on to off duty cycle of the MOSFETs to ensure that it can match the requirements that is needed. So when I talk about an efficiency with regard to the power supply, what happens here is that the on to off time, or the pulse width modulator, which is then triggering the MOSFET then to provide the required flow of current which is required then to run the amplifier, it will increase or decrease depending on load. Now, Often switch mode power supplies can fail in a number of ways. It could be a catastrophic failure where you have an output MOSFET which is just fails short circuit, blows the fuse, and hopefully it doesn't take anything else with it, but often it will. So you'll have additional parts of the circuit where it triggers the gate, for example, which is turning on and off the MOSFET. Those gate resistors can get damaged, or it can go back then to the switching device, i.e. the switch mode power supply integrated circuit, and often these are dedicated integrated circuits which are designed then for these types of power supplies. The critical thing here is, like a linear power supply, a switch mode power supply will also have, often for an audio amplifier, additional output voltages which power different sections of the amplifier, and this is what you see with this particular model here. So when I was measuring like for D30 and D29 on the plus or minus 15 volt supplies, D30 being short circuit, that was the issue. So it was effectively grounding it. Now all these power supplies have a number of different, shall we say, they'll have like a single protection circuit, but that single protection circuit is made up of other should we say measurement devices, right? So what I mean here is, within the power supply design there are what we call comparators, and what the comparators are looking for, these are integrated circuits, normally like dual comparators, and you will have a reference input on one side of the comparator, and then it will then be monitoring then the input on the other side of the comparator and then provide an output. And this could be monitoring, for example, over current, they may be monitoring for over temperature, could be monitoring for excess DC on the output. So all of these different measurement circuits, depending on the outputs, either they are high or low because of the comparator, that signal then is then fed directly then to the protection circuit, and then the protection circuit will operate. And this is what I was mentioning previously. On more complex designs, you need to determine, is it the amplifier that's causing the issue, it's triggering the protection circuit, or is the protection circuit faulty? Because I can disconnect the main amplifier board from the switch mode power supply, it's very easy to determine that, because as soon as I disconnect the main amplifier, I know that I can run the switch mode power supply offload, and I can make the necessary measurements and tests. If the power supply was then tripping back into protection mode, as it was here, then I know that I have an issue with the power supply. Okay, so you can see in the video, what I do is I'll replace the Schottky diodes, and I'll D29 and D30, both of them will be replaced. Now international rectifier 100422L devices, and I think they're actually obsolete now, so I hold in stock a conventional Schottky diode which I use on the Behringer iNuke and Nuke series of amplifiers, and then I just replace them. If you look and you make a search on my main channel, you'll see that there are repair descriptions for a range of iNuke amplifiers which have been repaired over time. And this failure of either one of the plus or minus 15 volt Schottky diodes, and the component reference will be different depending on which model of amplifier it is quite common. And when you think about the cost of this amplifier retailing at £580, and I understand that it literally was just outside of its warranty period, and then the customer then had a quotation which was nearly the cost of the amp. You know, you may well have already listened to the blog that I did with regard to, you know, the Teddy Pardo amplifier, and really how companies respond to that. You know, when you're paying £580, that is a chunk of money, I would say. And really you would expect, you know, the manufacturer to really look at that and say, look, you know, this amplifier, as it was almost like brand new. It hadn't really had a hard life. So for that then to fail because of that single diode, and then maybe the customer has to go and purchase another amplifier, to me kind of stings a bit and doesn't hold well. So once these both diodes were replaced, amplifier then was or the main amplifier board was reconnected, and then the amplifier via the dimple tester was put on test, and sure enough the amplifier powered up, and when you're in the initial test phase everything looked good, no issue at all. So you're checking the output then on the right channel, and you had good clear audio. There was no excess current being drawn on the dimple tester, but but the left channel there was no audio at all, and then when you checked, all inputs all good and no high DC. After a couple of seconds, probably a bit longer than that, maybe a few minutes, the amplifier went off. So I'm thinking, okay, well, kind of what's the issue here? So then I, of course, disconnect the power to the amplifier and then looking down, and then I look back at D30 and it appears to have moved. So I'm thinking, well, did I sort of maybe catch the diode when I was reconnecting the board connect to the main amplifier? So I get back in there and I then resolder it and repower again. Amplifier comes on, all good. And then what I start to notice is that it's actually the amount of current that is being drawn through D30 is excessively high, to the point where it's literally melting the solder, yet the protection circuit doesn't operate. So clearly the reason for the original failure is an issue with the main amp board. So you've probably got maybe 3 or 4 minutes here to make a test before it literally melts the solder and the diode falls over off the board. So again, getting in there with a thermal imaging camera, I'm moving it around, and then what I can see then is in the output stage, and you've got the Mosfet drivers, which are an IRS20957S, and the S series is the revised IC. The non-S version used to have some issues with noise, and you may see that on some of the earlier Behringer amplifiers, but now the 57S is the replacement for that. Unfortunately, if you try and source these, there just seem to be some supply issues, and a lot of the manufacturer or component suppliers are stating that the lead time is probably 3 or 4 months away. But in this case, I did have some in stock. So I'm using the thermal imaging camera. I can check IC16 IC17 and they are running hot. So okay, right, we have an issue in this output stage here. But before I undertook to repair or to replace the IRS IC16 IC17 Mosfet drivers, I made a number of static checks. So again, depowering the amplifier, I've got my multimeter on resistance. Power supply is disconnected, so there's no residual voltage, and I'm literally measuring all of the components in that area and comparing them to the working right channel. And there was no issue whatsoever. It was absolutely bizarre. You couldn't see any voltage change, any resistance changes, anything which was abnormal. So you say, okay, well, a little bit odd. And normally if you have, say, an internal short circuit within the component, like the Mosfet drivers, you would read that on the meter, but nothing. So okay, let's undertake to replace IC16 and IC17. Did that. Then powered up the amplifier, ran it back on test, and exactly the same situation. Excess current being drawn from the via D30. So you're really at this point where you can spend a huge amount more time and you may not still discover what it is that's causing that. So for this amplifier, it's really a two-part. So you can fix the power supply as was repaired, but there's nothing further you could kind of do with the main amplifier board. So then you have to go back to Music Tribe or the authorized distributor and repairer, respective country that you're in. So in this case, the sort of authorized repairer in the UK is a company called Ampman, and then go to them and say, look, the part number for the board, and you can see that this part number is shown in the video. So it's part number 703081, and it's a revision D-02, and then just do a complete block change of that circuit board. What is again concerning is that Music Tribe appear not to stock any kind of circuit boards for the Behringer amplifiers. It's the requirement then of the authorized repairer to stock them, and then in some kind of discussions with one of the other authorized repairers that I've previously dealt with, it seems that the import duty is really, really high on these boards, to the point where the authorized repairer, they couldn't, from a cost point of view, stock any boards on the shelf, just on the odd chance that you might need to use a board to repair an amplifier then. So really this is a two-part type repair. So once the board is replaced, then the amplifier then will be back up and working. The secondary fault here with the main amplifier circuit board, I would say, is not common. All right, so Normally you do find either one of the Schottky diodes is the issue. They could be open circuit or short circuit. This applies also to the iNUCs, as I said earlier. And once you replace those diodes, then you should be in a very good position, and you shouldn't require any additional work to fix a further fault. But not in this case. So I thought it was appropriate, just to do a repair overview. I know this is an amplifier that you can buy today, so it's not obsolete. And for anyone out there who owns one of these, or maybe you're undertaking repair work, that's all good, and hopefully you'll find this helpful. Concerning service manuals, Behringer or Music Tribe, they don't really allow any service data into the public domain. The only sort of service manual which could be located here was for the NX6000D. So the NX6000D, for the power supply and also for the main amp board, the component reference numbers change. So when I look at the schematic, it's effectively the same, except on the 6000D, of course, you'll have a higher output stage, but the power supply is fundamentally the same, and you can use that then as a guide. These amplifiers, are they easy to repair? I'd say not really, because like in this fault, at least you can split it out, but it is a combination of surface mount and conventional, so it makes fault find a little bit more difficult, because you kind of got to get in there and get the boards up, to make the necessary measurements. But with the service manual, it's going to help you a lot. And again, if anyone is out there and they're looking to repair one, by all means, email Audio Amplifier Servicing at AOL.com, and I'll be more than happy to email across to you the service manual for the NX6000D, and hopefully that will help you. So that's everything all covered for this particular repair. So I thank you for listening, and until the next time. Thank you. Bye bye.